rock you. We will rock you. Oh! It is a very good day to rock on. You and I are going to learn a new topic in science. Are you ready to be a science terrific? Because you should be. I am Teacher April, and our topic today is about rocks. Rocks. The study of rocks is called petrology. What if we told you that rocks are not all the same? Yes, there are 3 types of rocks. So, at the end of the lesson, we are expected to classify the 3 main types of rocks, which are igneous, sedimentary, and metamorphic. But before that, we will have a game. This game is called a Rocky Road game. You will say rocky if this sentence is true. You will say road if the sentence is false.
Answer as quickly as you can. Pumice is an igneous rock that came from a molten rock. The answer is rocky. Breccia is a rock that undergone weathering and erosion to become a sedimentary rock. The answer is rocky. Peat is a sediment of plant remains. The answer is rocky. Marbles are metamorphic rocks. The answer is rocky. And the last one, sedimentary rocks are rocks that undergone the process of heat and pressure. The answer is road.
So maybe you are asking, why do we need to study rocks? We need to study rocks because rocks holds the history of the earth and the materials that we will be using to build its future. But how do we classify rocks? We can classify rocks by studying them, by knowing the process that they have undergone in order for them to become igneous, sedimentary, and metamorphic.
Welcome to our lecture proper. I encourage you to get your pen and notebook to take note the important information regarding the topic, the 3 main types of rocks. I am your teacher, April Love Ganibe. Where do rocks come from? Maybe you are still wondering, where do rocks come from? As strange as it sounds, rocks are made from star dust. Dust blasted out and made from exploding stars. In fact, our corner of space has many rocks floating around in it. From really fine dust, to pebbles, to boulders, and house-sized rocks that can burn up in the night sky to make meteors or shooting stars. The moon and our local planets, the Mars, the Venus, and the Mercury, are just the largest rocks floating around our part of space. These are all made from space dust, stuck together over billions of years. The planet Earth is a rock too. But so much has happened since it was formed from dust and small rocks that smashed and stuck together 4.5 billion years ago. As the space dust hit each other to make the Earth, it got super hot and melted. The Earth was at the time a spinning ball of red-hot lava flying through space. In this melted lava planet, heavy bits of the Earth sank, and the light frothy bits gathered on the surface. Have you ever looked closely at a glass of milky coffee at a cafe? The dark, heavy coffee is at the bottom, whereas the light, frothy milk sits on the top. Well, our planet was a bit like that coffee billions of years ago. We don't see the really heavy rocks these days because they sank deep in the planet very early on. The rocks we see on the surface are like the frothy milk. They were light and rose to the top. Then, as time moved on, the planet cooled down and froze to become the solid Earth we have now. I know most of the rocks are heavy, but in fact, some rocks, even really big ones like Uluru, are actually much lighter than the rocks found in the deep Earth. What a trivia! Those rocks on the planet's surface actually moved around. Large chunks the size of continents, we call plates, jostle each other, and this can cause earthquakes. Some of them get forced under other plates and heat up. Eventually, they melt. This forms more lava. The lava erupts from volcanoes, then cools down, and then forms new rocks. So this is now our topic, how these three main types of rocks are being formed. Most of the rocks are igneous rocks. Rocks are mostly found in oceanic crust and on continental crust, in which humans can directly access. Also, we can see that one type of rock can be transformed into another type, depending on the process that it goes through. These are the three main types of rocks: sedimentary, igneous, and metamorphic. The sedimentary rocks are formed by the compaction and cementation of sediments, a process called lithification. Rocks have undergone weathering and erosion, and these are the sedimentary rocks. Common sedimentary features are strata. Greater than 1 centimeter is called bedding, and anything less is called lamination. Layering is the result of a change in grain size and composition. Each layer represents a distinct period of deposition. Fossils, the remains and traces of plants and animals that are preserved in rocks. This is an example of bedding. This shows the fluid flow. This cycle repeats with each layer preserving the previous one. These are the fossils, remains and traces of starfish and shells, trace of leaf of the plant, and traces of sea waves. We have asymmetrical ripple marks and symmetrical ripple marks. And this is an example of animal remains. Sedimentary rocks are classified into classic and non-classic. How do we tell the difference between chemical and classic sedimentary rocks? When we say chemical, these rocks are formed by the precipitation of minerals, while classic, the rocks are formed through compaction and cementation. Classic sedimentary rocks are made up of sediments from pre-existing rocks. When pre-existing rocks are physically weathered and eroded, they form sediments. When these sediments are transported, deposited, and lithified, they form the classic sedimentary rocks. These rocks can be identified based on their grain sizes. The non-classic sedimentary rocks can be biological or chemical, or a combination of both. Biological sedimentary rocks are lithified accumulation of dead organisms. Examples include coal and limestone. Chemical sedimentary rocks are from chemical precipitation. Example, rock salt. The classification of these rocks are through textures and composition. This leads to story of rocks formation, setting, and history. We have detrital-clastic or the rock and mineral fragments, and the organic-clastic, which is shells. The mud-sized grains. The detrital-clastics, which in sandstones, and these are in mud-sized clastic rocks. The chalk, the mudstones, and the diatomite. The chemical rocks, which are formed in precipitation of minerals from cold saturated solution or near Earth's surface. These minerals are calcite, halite, quartz, and gypsum. Calcite may form limestone, quartz may form chert, and this one is the rock salt. These are the examples of the image of chert and the limestone. The uses of sedimentary rocks. They are used in oil, natural gas, coal, and uranium. Our major energy resources are formed in and come from sedimentary rocks. The sand and gravel for construction come from sediments. Sandstone and limestone are used for building stones. Rock gypsum is used to make plaster. Limestone is used to make cement. Salt is used for flavoring. And phosphate-bearing sediments rocks are used for fertilizer. And the quartz sand is used to make glass. Next is igneous rocks. Igneous is the Latin word means fire. Igneous rocks are rocks that are formed from the solidification of molten rock material. These are the magma or the lava. Igneous rocks are further classified as intrusive or extrusive igneous based on grain size. The intrusive rock igneous rocks are also called plutonic rocks. These are igneous rocks formed from solidified magma underneath the earth. Or the extrusive igneous rocks is also called as the volcanic rocks, which are formed on the surface of the earth. When we say lava, these are the molten material that is on the surface of the earth. While when we say magma, these are the molten material which are underneath the earth. The igneous rocks are formed when lava or magma cools down and solidifies. If the lava or magma cools quickly, it has small crystals. And if the lava or magma cools slowly, it has big crystals. So, the difference between extrusive and intrusive igneous rocks. Extrusive igneous rocks, also known as volcanic rocks, while intrusive, also known as plutonic rocks. In extrusive, the lava cools down quickly on the surface of the earth, while intrusive, magma cools down slowly underneath the earth. Extrusive rocks has smaller crystal formation, while intrusive rocks has bigger crystal formation. And these are the igneous rock samples. We have them, the composition and the texture. We have 5 types of textures. The phaneretic, which is 100% visible crystals. Then the aphanitic, which are most crystals too small to see. Then the glassy, 100% glass. The frothy, greater than 50% vesicles. And the pyroclastic, the fragments of ash crystals, pumice rocks. So the compositions has 4 types: the ultramafic, the mafic, intermediate, and the felsic. So these are the examples of the rocks under their texture and the composition. The composition of the igneous rock depends on the layer which is formed. When it is formed in the mantle, it is ultramafic. As it goes up and evolve or melt, that is mafic. And if it is formed near the Earth's crust, it is the intermediate or felsic. Pyroclastic examples are the volcanic tuffs, felsic, higher silica viscosity and gas like water. So the pyroclastic has pumice and the rock chunks here. So the volcanic tuff. The frothy texture example of rock are scoria and pumice. So these are the vesicles of these rocks. Comparing the two, pumice is less denser. Scoria is under the composition of mafic, while pumice is felsic. Scoria is denser and generally darker in color, while pumice is less dense and generally lighter in color. Next is the glassy. The only one example for that is the obsidian. Next is the aphanitic. They have the hornblende phenocryst, and this is the closer look of that hornblende phenocryst. And this rock is called the andesite. This one has plagioclase phenocryst, and this is called the plagioclase basalt porphyry. What are the uses of the igneous rocks? Extrusive rocks like pumice can be used as the lightweight concrete. Obsidian can be used as ornaments like earrings. And then the intrusive rock like granite and diorite can also be used as concrete material for our buildings and houses. The metamorphic rocks. Morph means to change in form. Are formed by pre-existing rocks that are exposed to extreme heat and pressure in the Earth's interior, a process called metamorphism. These are the examples of metamorphic rock. So from pre-existing rocks, the granite, when it undergoes heat and pressure, it becomes gneiss. Sandstones becomes quartzite. Shale becomes slate. So they are from the parent rock that receives heat and pressure and chemically active fluids and then change in form. That's why they are called metamorphic rock. These are their classifications: non-foliated, weakly foliated, and foliated. The naming leads to parent rock plus the metamorphic setting. So these are the diagram that shows how deep the rock goes here and how great the pressure they receive and how high the temperature they receive. The higher the temperature, the greater the pressure, and the deeper they are inside the earth, the increase in metamorphism that they are formed. So from limestone, they become now as marble quartzite. From basalt to hornfels, from mudstone, shale, slate, phyllite, scheistose, they could also become magnetite as it goes deeper. Limestone becomes marble and the shirt becomes quartzite. Then the gray wax sandstones, when added heat, it becomes carn. And when the peridotite and hot water is added, it becomes serpentinite. The limestones change into marble, which are also called as the 100% calcite rock. The shirt changed to quartzite. These are their textural clues: foliated and non-foliated metamorphic rocks. Foliation, alignment of minerals. Foliation of minerals is the alignment of minerals. No foliation, there is no alignment of minerals. The alignment of biotite and quartz and ilmenite crystals in a slate. So this is it. The foliation alignment of minerals called kyanite, actinolite, and epidite. Let's have an activity, so get your pens and pencils, as many as you can. You may pause the video. Gather your pens and pencils and spread them on the table. Put your right arm or hand on the right side of the table, your palm facing the pens and pencils. Put your left arm, hand on the left side of the table, your palm facing the pens and the pencils. Slowly move your both arms, gliding towards the pens and pencils. Next is, what happened to the pencils and pens? So the pencils aligned when they receive pressure that is exerted by your both arms and hands. These are an example of metamorphic rocks, the phyllite, the schist. When there is an increase in metamorphism, from slate they become schist. And then phyllite, when there is an increased metamorphism, it becomes gneiss. This is gneiss, the combination of mudstone and granite. When there is very high pressure received by it, it is foliated. Increase in temperature like migmatite will have more foliated structure. And the serpentinite is in a weak foliation when it is rising up in the rocks. The non-foliated metamorphic rocks. If minerals can foliate but haven't, the rock was not subjected to directed pressure. Example of this is this one, the skarn. From sandstone to skarn, they use crystal size and composition for grading. From mudstone or basalt to hornfels. And these are the non-foliated rocks, the skarn, hornfels, marble, and quartzite. They have the same metamorphic setting but different parent rocks. They all under the influence of heat and pressure. That's why the rocks change in form. Foliated has layers, non-foliated has no layers, and weakly foliated rising up cracks. Some uses of metamorphic rocks. Marbles are used in building constructions, quartzite is used in road construction, serpentine rocks are used to make asbestos in industrial uses. So this is the rock cycle. From metamorphic, it could change into igneous rock when received melting, cooling, and solidification. The igneous rocks will become sedimentary rocks when the sediments undergone weathering and erosion and then compacting and cementing. The sedimentary rocks may form metamorphic rocks when it receives heat and pressure, and the cycle goes on. Let's review. What is the type of rock is in this box? When it undergone weathering and erosion, deposition of sediments, and boreal and compaction. Next is when it receives extreme heat and pressure, what type of rock it is. Next, When it undergoes melting, crystallization, and solidification, what type of rock may form? Let's check your answer. To summarize our lesson today, we will be singing this song in tune of We Will Rock You. In 3, 2, 1. There are 3 types of rocks. Igneous rocks are rocks that are formed from solidification of magma or lava. They undergone cooling, which one? Important factors that control crystal size. Extrusive rocks are formed on the surface of the earth, basalt on the side. Intrusive rocks are formed from the solidified magma, granite gabbro. Igneous rocks, sedimentary rocks that are formed from weathering and erosion. Their small sediment turns to shale, then the gravel turns to conglomerate. Non-clastics can be chemical or biological or combination. Clastics are sediments from pre-existing rocks like breccia. Sedimentary rocks. Metamorphic rocks are formed from the transformation of pre-existing rocks. Metamorphism occurs in response to heat, pressure, and chemically active fluids. Foliated have layered appearance, nice lay. Non-foliated don't have layered appearance, marble quartzite. Metamorphic rocks, so we will rock you, we will rock you. Good job! I hope you enjoyed the song. Answer this in your notebook. You try to classify the different types of rocks into sedimentary, igneous, or metamorphic. Number 1. Conglomerate. Number 2. Pumice. Number 3. Marble. Number 4. Obsidian. Number 5. Gneiss. Number 6. Limestone. Number 7. Rock salt. Number 8. Sandstone. Number 9. Basalt. Number 10. Andesite. Please pause the video. Okay, so let us now check your answer. You may pause the video to check your answer. Let's try another. What you can do? Copy and answer. You may pause the video. The types of rock in the first column. Process that they undergone in the second column. In the third column are their classifications. And then, in the fourth column, are the examples of rocks. Okay, so let us now check your answer. You may pause the video to check your answer.
In today's lesson, we have learned that we may encounter changes in our lives. We may encounter different problems. Just like stones, either they are big or small, that life may give you and hit you. Remember that God will always guide you and protect you, because God is our rock.
Based on the objective of this module, you must classify rocks into igneous, sedimentary or sediments, and metamorphic. Write your answers on the space provided. But this time, you will write the answer in your notebook. Number 1. Basalt or basalt formed by the cooling or solidification of magma or lava. Number 2. Gravel formed by the cooling or solidification of magma or lava. Number 3. Marble formed by pre-existing rocks that are exposed to extreme heat and pressure in the Earth's interior. Number 4. Peat is a blank. Number 5. Conglomerate formed by the compaction and cementation of sediments. Number 6. Andesite formed by pre-existing rocks that are exposed to extreme heat and pressure in the Earth's interior. Number 7. Limestone formed by the compaction and cementation of sediments. Number 8. Gneiss formed by pre-existing rocks that are exposed to extreme heat and pressure in the Earth's interior. Number 9. Clay or mud is black. Number 10. Pumice formed by the cooling or solidification of magma or lava. Okay, let us now check your answers. You may pause the video to check your answer. Let us have an agreement. You will be doing this during your leisure time. To sum up everything that you have learned from this module, choose one task to do. Choose one task to do. Illustrate the rock cycle. Make a song about the types of rocks and their process and examples. Make a reaction video or vlog demonstrating your understanding about the 3 types of rocks. Or, you may take pictures of the different types of rocks that you have found in your environment, identify them based on their properties. You can name them and make a sample portfolio of the 3 types of rocks using the gathered data. But please, wear your mask when you go out.
I know you enjoy learning about rocks. See you next lesson. This is Teacher April saying, if it is hard, it is worth doing. So keep it up and have fun learning, because knowledge is science.